Hey YouTube, DeVore here again, and today we're going to talk about the 2.3 task in the Mathematics Vision Project Math 3 textbook called Chopping Logs. We're about halfway through the logarithm module, and we're going along at a pretty good pace. This activity is talking about some of the other logarithm rules that we haven't talked about yet. And let's just go ahead and look at this. So here we have the function y equals log base 2 of x plus b. I really hate they use plus, just so you're aware. It should be x minus b personally. I started to think that maybe I could just distribute the logs so that I get log base 2 of x plus log base 2 of b, saying these should be equivalent expressions. I'm going to tell you right now it doesn't always work that way. Let's do a test case. So I'm going to use log base 2 of x plus 1. And I'm going to plug in x equals 1. Let's just keep our numbers simple here. So using his logic, we should have log base 2 of 1 plus log base 2 of 1. Please put them in parentheses, makes it easier for me to read. Log base 2 of 1 is 0 plus 0 equals 0. Okay, let's see what this actually is. Log base 2 of 1 plus 1 equals log base 2 of 2 equals 1. Uh-oh. These numbers don't match up, which means this does not work as Abe wants it to. So let's see what actually works. I just know there's something going on with these logs. Here is log base 2 of 4x. Let's get a couple important points here. There, and there. So we've got a point at 1, 2, and then 2, 3, and 4, 4. So we know that the asymptote's the same, but it kind of looks like it's been maybe shifted up a little bit. Let's experiment with that a little bit. So when we have our actual function, we have 0, 1, 1, 0, 2, 1, 4, 2, 8, 3. So that's what it should be. These red points not on a line. And you could see that in order for us to get our other function here, we shift up 2. So let's go ahead and write it here. Log base 2 of 4x equals log base 2 x plus 2. So that's our vertical shift. And we should be able to see that just from the graph here. Okay. I wonder why the vertical shift turned out to be 2 when the x was multiplied by 4. I wonder if it has something to do with the power that the base is raised to, since this is a log function. So we want to try and find our equivalent equations here. So this is log base 2 of 8x. Once again, I'm going to find a couple important points that will make our lives easier. And then I'm going to, like before, draw what it should be. So we've got 1, 2, 1, 4, 2, 8, 3. Now you should notice, if we look at the vertical shift, we add 3 to our original equation for each one of these. So we've got log base 2 of x plus 3. And we're going to do it again. Boop, 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 and boop. Okay. 1, 2, 4, 8. Let's count. We've got 1, 2, 3, 4, 1, 2, 3, 4. Looks like we're shifting up 4. Log base 2 of x plus 4. Oh, okay. So when we multiplied by 8, we added 3. When we multiplied by 16, we added 4. Okay, interesting. So here are, just as confirmation, here's what we have. So here's what they noticed, is that when we're multiplying, we have 4x. Well, we know that log base 2 of 4 is 2, log base 2 of 8 is 3, log base 2 of 16 is 4. What they noticed is that we're splitting up the logs just on the multiplication side. So when you have two things multiplied together on the inside, you can split them up by adding. And I'm going to tell you right now, this is true. In fact, it doesn't matter what the base is. This is true. This is one of our logarithm rules. Now you might be wondering to yourself, why would I ever want to split up numbers like that? Well, back in the olden times, before we had calculators and computers, if we wanted to do multiplication of really big numbers, it might be easier to think about it in terms of addition. This is what made slide rules a thing, is being able to take advantage of a bunch of addition problems, which are frankly easier to manage than really big multiplication problems. Okay. Now we're gonna go the other way here. Now we've got division. Let's find our important points here. Blink, blink, blink. And once again, we're going to say what they should be. Let's find one more. Let's see, we've got.
Stuart, could you please stop by and see that your machine is when you have
looks like we are shifting down 2. So log base 2 of x shifted down 2. Let's see if that holds true. Now, my hypothesis here is that we have x divided by 8, so this should be shifted down 3. It's a good guess. Let's see if it actually works out. And lo and behold, that's how it works. Log base 2 of x minus 3. Use these examples to write a rule for division that looks like the rule for multiplication. Log base 2 of a over b equals log base 2 of a minus log base 2 of b. So this is yet another rule. Yet another rule. So here we have the multiplication rule, and we're going to see if we can create a power rule. Because here we have log base 2 of x to the third power. So we have log of x times x times x, which is just the definition of an exponent. And then he was able to split them all up using our multiplication rule. And so we've got 1, 2, 3 of the same thing, which means we have 3 log base 2 of x. So this should be true. And I'm going to tell you right now that this is our third logarithm rule. And you can expand the proof that Abe did for any power that you want. In fact, I've had students who didn't know this rule, but knew the multiplication rule, and were able to essentially derive this kind of by accident using these exact same steps, which was frickin' awesome, and I loved it. So if all else fails, if you don't remember this power rule, you can always use the rules of exponents to derive it by hand. That totally works. Okay. So here are what should go in your notes. Boop, boop. So, yeah, I'm not drawing straight lines very well. These are the 3 logarithm rules that will last you through the rest of this module. it makes it so that you can split up any expression, so long as it includes multiplication, division, and exponents, into something that is a little more manageable. Now you may be thinking to yourself, well, that's cool, but why? That is something that we're going to tackle in the 2-4 task. One more thing here. It asks, how are these rules similar to the rules for exponents? Well, if you remember, for instance, we have the product rule. We have the quotient rule. And then we have a power of a power rule. That should be an X, sorry. I just got kind of caught up on the A's here. There we go. So notice that when we multiply two things with the same base together that have different exponents, we can add the exponents. Division is subtraction. And products, we multiply. That's the same kind of idea here. When we multiply, we add. When we divide, we subtract. And when we have powers, we multiply. It's the exact same idea, just exponents versus logs, which that should make sense. That should work, because remember that exponents and logarithms are technically inverses of each other. So it makes sense that some of these rules of combining exponents would also match up with our rules for deconstructing, for taking apart logarithms. All right, that is the 2.3 task called, let me get the name of it again, called chopping logs. So thank you so much for joining me for this video. If you have any questions, please feel free to email me and I will answer your questions as best I can. Please remember to like and subscribe if you like these videos, and I hope to see you all in the next video. Have a great day. Bye-bye.